Hi students. So this is a problem which is given in Newton's laws of motion. Now let us try to do this problem. Here there are two cases. As you can see the problem here, this is the first case and this is the second case. In these two cases the question is that on applying a force capital F, point P is displaced vertically down. Okay, now this point P, here this point P is displaced vertically down to a distance of y from equilibrium position. Now find the force in terms of the force constant. Here we have to write the force in terms of K and Y. In both the cases we have to write in terms of both K and Y. We should write F in terms of K and Y. So first of all here we all of us get confused whether suppose if this force is applied in this, okay na, and if we just move this string to a distance of y, then we may get confused that this spring to how much distance it move. Okay, that is a little bit confused. Okay, now means if this string is displaced to a distance of y, and here actually the spring will be displaced to y by 2. How is it? See, in the bottom I have taken one problem. In this we know that work done, when we come to do the problems, when we do the problems regarding constraint equations, there we used to do this type of problem. Net work done due to tension. Net work done due to tension is 0 in this total situation. Am I right or not? So that's why work done due to tension means on M1, let us assume that M1 is moving upwards and M2 is moving downwards, whatever it may be. Actually M1 will move downwards, it may move downwards also. But the thing is, we have to write work done due to tension on M1 and M2. Work done formula is what? Force into displacement. No? Here the what is a force? Tensional force. If this is T and this is T, then what is the tensional force here? 2T. On M2 the tensional force is 2T. Therefore, first writing work done on M1, that is T into x1. Let us assume that M1 moves to a distance of x1 minus why we are taking minus y, because tensional force on M2 is upwards but the displacement is downwards. That's why if force is upwards and displacement is downwards, therefore we can write it as 2t into x2. This is a net work done due to tension in this total system, which is equal to 0. Therefore x1 minus 2x2, if we take t as common and send to that side so that it will become 0, therefore x1 is equal to 2x2. Just keep this in mind. Okay, now what am I doing is, see in this situation, okay, same thing you just apply to this one, same thing. Okay, now if this string or M2 moves to a distance of y in the downward direction, which means that if x2 is equal to x, then what is x1? X1 means this one. M1 moves to a distance of x1 in the upward direction, which means that this pulley is there, this pulley, movable pulley, this will go to how much distance, or this string moves to how much distance. That is what we have to calculate. Therefore x1 is equal to 2x. Okay, now what does it mean? It means that if M2 comes to a distance of x in the downward direction, then this string, okay, now will come in the downward direction to a distance of 2x. So if this comes to a distance of x, then this comes to a distance of 2x. Same thing you can apply here. So from this, if this moves in the downward direction with a distance to a distance y, then the spring will move to a distance of y by 2, as we have seen from the previous example. So let us take the first case. Now I'm writing the solution. I'm taking the first case. In this, we know that whatever tensional force is a self-adjusting force. Whatever the force we may apply on the string, the same tensional force will be developed. Therefore, F is equal to T. Why? Because tensional force is self-adjusting force. F is equal to T. And here, therefore, if this is a tension T, and here also if this is a tension T, then what is a tensional force in the upward direction here? That is 2T. Therefore, 2T is equal to 2T is equal to means that same 2T will be applied on that spring also, means that 2T will be equal to the restoring force which is developed in the spring. The 2T is equal to the restoring force which is developed in the spring. What my point on it? Now, what is that restoring force? Here, restoring force formula is F is equal to Kx. As F is proportional to minus x, actually F is equal to minus Kx. Okay, now. So therefore, here, if the string is displaced to y, then as we have seen in the previous example that I have told you, then spring displaces to y by 2 distance. So from this we can say spring force is equal to, what is the spring force here? Spring force is equal to K into, what is the displacement moved by the spring? It is y by 2. Therefore, this is Fs, and substitute this Fs in this 2T is equal to Fs. Therefore, we can write that 2T is equal to K into y by 2. That is, T is equal to K into y by 4. What is this T here? This T is nothing but the applied force. Therefore, finally we can write the applied force F is equal to Ky by 4. In what case? In case 1. This is in the first case. Then let us see in the second case. In this second case, suppose if this point P is moving to a distance of y, then similarly this is quite opposite to that of the first case. If P moves to a distance of y, then the spring will be elongated to a distance of 2y. Yes or no? Same thing we have discussed here, but we are discussing it in reverse, right? So if point P displaces to y distance, then point P displaces to y, then spring will be displaced. Spring will be displaced to y. Yes or no? Therefore, here if this is 2T tensional force in the second case, therefore it is T, it is also T. Then the tensional force is equal to the restoring force. The tensional force is equal to the restoring force, that is Fs, and it is equal to K into 2y. K into 2y. Yes or no? K into 2y. Okay now. Then therefore T is equal to 2ky. Then we have to write, we should not write T, we have to write F. Therefore F is equal to, in this F is equal to 2T. Why? Because see here at the equilibrium position F is equal to 2T only, no? Upward force is 2T here. Therefore F is equal to 2 into, okay na, T value 2ky. T value is what? 2ky. Therefore 2 into 2ky, which is equal to 2 into 2, 4ky. This is in the second case. That's it. See, these same problems are there Okay, in simple harmonic motion, and there we will find out the time period. Okay, now we used to find out the net force and we used to find out the time period of these two, and I'll discuss you that in the next class. Okay, thank you.